This is an example to show how to find the t-test for a two-sample independent t-test using R. The first thing to do, of course, is type your data set into R. So we'll start with that. This case is we're dealing with hot dogs and the amount of calories in hot dogs. So we're going to have our hot dogs as our data set. We're going to read in a CSV file, and here's the web address of the CSV file. Now, as always, you should do a head of the data set to see what the data set is structured like. So this one has type as the first variable. The second variable is calories, and it has a third variable of sodium. Being that type is one of the variables, my guess is that this data set contains both beef and the poultry. So we're going to go ahead and have to do a filter of the data set to pull out just the beef calories and sodium, and then we'll do the same thing with the poultry. So we're going to call this data set beef. Then we'll deal with doing the data set hot dogs. And we're going to take from the hot dogs the variable hot dogs. For the data set hot dogs, then the variable is type. We're going to have that equal, sorry about that, we're going to have that equal beef. And I've now just created that new data set. Do the same thing with poultry. Remember that this is in brackets. And this one's going to be poultry. And I've just created that data set now. In a hypothesis test, you have some assumptions. So we should look at those assumptions to see if they're correct. One of the assumptions is a normality assumption. So we have we assume that the data set, the population of calories for the beef hot dogs is normally distributed. And we assume that the population for poultry hot dogs of the calories in those is also normally distributed. And the test for that is to look at the histogram, the QQ norm plot, and the box plot. So we'll start off with the normal quantile plot, or the QQ norm plot, and we'll do it for the beef first, and we want to do it on calories. So we'll create a QQ norm graph for the beef variable, beef data set, on the variable calories. This data set, shrinking it down a bit so you can see it. The QQ norm plot looks like this, and it looks fairly linear. Not perfectly, but fairly linear. So we'll do the same thing with a histogram. We'll do a histogram or hist of beef on calories. Helps if I spell beef correctly. Then we can hit the up arrow and bring it back up, and then you can just arrow over and edit the thing you want. And then we'll look at that window and that graph. And this graph doesn't really look bell-shaped, but looking at this, I'm not sure. There's a lot of data values here. So it probably could be. There's a big hump in the middle, and then there's this one over here that's a little off. So I'd say we can go ahead and say it's bell-shaped. And then let's look at the box plot. And that's box plot. And that graph looks like this. Since there's no dots above and below, it means it has no outliers. So therefore, I would say that we probably are normally distributed for the population of calories in the beef. We'll do the exact same thing for the the poultry. I did the histogram first. It really doesn't matter which one you do first. You want to look at all three. That does not look at all bell-shaped. So we're going to go ahead and look at the QQ norm plot. And that one looks somewhat linear, not perfectly, but somewhat linear. And then let's look at the box plot. and that one has no outliers. So I'm not so sure we can say that this population, the population of the calories in poultry, is normally distributed, but it's probably not too far off. All right, so now we can actually go do the hypothesis test, that is t-dot test, and then we're going to do our two random variables. The first variable is beef, and that is calories. We're doing beef calories. Our second variable is poultry, and the calories also. And then you don't need to do anything paired because it's false, so we don't need to type that in. And alternative is greater because we are saying that beef is going to have a higher calorie count than poultry. And since beef we wrote first, we do want greater. If you hit enter, I know I did the correct test because this is called the Welch's two-sample t-test. It tells me which variables I worked with, and it gives me my t-value of 5.11, my degrees of freedom. If you use the formula, that awful formula, this is how many degrees of freedom you come up with, and then the p-value is calculated based on that degrees of freedom and your test statistic. It then tells you the alternative hypothesis. True difference is greater than 0, which is good because that's what we were hoping for. It gives you the confidence interval, but this is irrelevant to us. And it also gives you the sample means in case you want them. It calls sample mean X and sample mean Y. That's X1 and X2. And there you have how to find a two-sample independent t-test on R.